Hello everyone. So in today's video we are going to solve a problem which is based on Jahn Teller distortion. So before you go through this video, please revise about Jahn Teller distortion. You can use any of your resources, your books or tutorials or videos. So just you have to revise what is Jahn Teller distortion, what are the conditions and the examples, and then only you can attempt this question. Okay, we will briefly talk about it and solve this question. And it says that which one of the following octahedral complexes will be distorted. So from this word distorted, you understand that it is talking about the Jahn Teller distortion. Okay, here are the four options. We have a chromium complex with aqua ligands. So all are aqua ligands. So all are having 6 aqua ligands, and that's why these are all octahedral complexes. And then we have a chromium plus 2, then chromium plus 3, and option C has manganese plus 2 and iron. Option D has iron plus 3. Okay, let us check out these four one by one. We can also see in this question that all these ligands are the aqua ligands. From A to D we have H2O. All are aqua ligands, and we know that H2O in the spectrochemical series is a weak to moderate ligand. So aqua or H2O here will be acting as a weak field ligand, and all these complexes will be the high spin complexes. Okay, so this we have to take care while writing the valence electronic configuration of the central metal ion in these complexes. So the first one with hexa aqua chromium plus 2. So we know that the valence electronic configuration of chromium is 3d5 4s1. Now what should be the valence electronic configuration when Cr is in the plus 2 oxidation state? So it is 3d4 and there is no electron in the 4s orbital. So it is 3d4. Now coming to the next option, we will discuss about the filling of these electrons once we have the valence electronic configuration of all these ions. In the second complex, chromium is in the plus 3 oxidation state. Now what should be the valence electronic configuration? So in the plus 2 state, you saw this is 3d4. So in the plus 3, it is 3d3. Okay, now moving on to the manganese complex. So the electronic configuration of manganese is 3d5 4s2. We all know that. And what happens when this is in the oxidation state of plus 2? So it becomes 3d5 4s0. Now the last option is FeH2O 3+. So iron in the ground state will have 3d6 4s2 valence electronic configuration. And then in the plus 3 state, what should be the valence electronic configuration? So it should be 3d5 and no electrons in the 4s orbital. Okay, so from Jahn Teller distortion, we know that distortion from the regular geometry can occur if any of the T2G or EG orbitals are unsymmetrically filled. Okay, and more distortion occurs when EG orbitals are unsymmetrically filled because they come in the direct path of the ligands. Okay, now let's check out how to fill, how these electrons after we have their proper oxidation state valence electronic configuration, how these will be filled. So coming to chromium plus 2. So in the first option we have chromium plus 2 with D4 valence electronic configuration. So D4 means, so this can fill like this, 1 electron each according to the Hund's rule, T2G, and 1 electron goes to the EG. And here we can see that T2G is symmetrically filled. All the 3 orbitals have been occupied with 1 electron each. So this is symmetrical. While EG orbital in this case is unsymmetrically filled. Okay. Why? Because there are 2 orbitals while only one is filled with 1 electron. So this is an unsymmetrical filling of EG orbital. Option B, chromium in +3 oxidation state. So in +3 oxidation state, we just saw what happens in the +2 oxidation state. So +3 oxidation state, we have D3 electronic configuration. So D3 means the 3 electrons should fill in the T2G orbital singly. And this is a symmetrical filling of T2G orbital. Okay, so symmetrical filling. So that means no Jahn Teller distortion. Fine. So in the first option, we saw EG was unsymmetrically filled. So it has a probability of showing Jahn Teller distortion. Now in the last two options, in option C, we have manganese +2, which has a D5 configuration. And also in the last option D, we have Fe3 ion, which again has a D5 configuration. So what happens in case of D5 configuration? So in case of D5 configuration, each orbital should contain 1 electron each first. So 1, 2, 3, 4 and 5. So what happens here? So you can see that EG is also symmetrically filled. 2 orbitals have 1 electron each. T2G is also symmetrically filled in a D5 configuration. All the 3 orbitals in T2G occupy 1 electron each. So this is symmetrical filling. That means in these two cases, C and D, also there is no possibility of Jahn Teller distortion. So that means we only have this option A with chromium +2 oxidation state where EG is unsymmetrically filled and we have the possibility of Jahn Teller distortion. In B also we saw D3 configuration, all the 3 electrons occupied like this, so no JT distortion in option B. Option C and D has D5 configuration where also T2G and EG orbitals are symmetrically filled. So again there is no option for Jahn Teller distortion. So we are only left with option A where Jahn Teller distortion is possible. Okay, so what should be the answer of this question? So option A should be the correct option for this question. It's not a very tough question, it's an easy one. You just have to know the concept, just have to know the valence electronic configuration and how to fill these electrons in the respective T2G and EG orbitals. And what are the criteria of symmetric and asymmetric filling. Okay, I hope this explanation is clear to you and hope it is helpful. Thank you so much.